We'll begin our study of mechanics by looking at a chapter on measurement in vectors, chapter number 1. The section we're now going to discuss is data, units, and metadata. Well, since the beginning of time, people have had to measure things quantitatively by counting, whether that's counting their sheep or goats or animals or people or whatever it may be. Counting from the beginning has been the way of keeping track of things in a numerical and more exact way. And as I write here, for thousands of years, the scientists have used our mathematics to represent scientific information. And that consists usually of a numerical value in units and something that tells us what this metadata is. For example, you might have, as I've written here, 4.6 kilograms, and we want to know what that 4.6 is. If we don't know a unit that it's in terms of, or a ratio to what, then the 4.6 is kind of meaningless by itself. Here we're saying that the 4.6 is measured in kilograms, implying a mass. But 4.6 kilograms of what? We know we have an abstract mass at this point, but what is it? And in this particular case, it might be brown rice. And you'll notice that there are three parts to this. The first is the numerical part. It gives what we call a real number. That is an integer followed by a decimal point and more digits that give us the value to any desired degree of accuracy that we want to carry this. Secondly, a unit that tells us what units we're measuring this in. And finally, some type of information that's descriptive about the what we call metadata. That means beyond data, beyond this data information here. And we now know that we have 4.6 kilograms of rice. Now the number would be real. It could be an integer. It could be a vector. It could be a complex number. This number could be a tensor array. What are examples of that? Well, you know what an integer is. It'd be something like 4. It could be a fraction, although we don't normally use a fraction in what we write. It could be 4/11ths. But more normally what we would do is we would write this out in a decimal form. It could be a vector, like 4, 3, meaning the x and the y coordinate, so that this could be a vector that we're talking about in terms of kilograms. Or it could be a tensor array, which means an array of numbers like 1, 3, 6, 2 in a square array, or even a three-dimensional or another type of array. So in general, this could be a rather complicated mathematical numerical form, and this would normally be units, and this would be some type of metadata telling us what this is. And of course the metadata could be very extensive. It could tell us that it's brown rice of a certain type, of certain quality, from a certain field, at a certain longitude and latitude, and so this metadata might be quite extensive. I've written it this way. You won't normally see all of this, but to emphasize that we do have three parts to this. Our data, which is our number, the other part of the data, which is the units that data is in, and then finally some type of metadata that tells us what that really means. Well, of course, with the early English units, we used things that were around as people went around as hunters and gatherers and farmers, and they had the parts of their body, and if they would use these parts of their body to do their measurements because they always had them. For example, you had units like I'm going to mention here. You had for length, you had an inch. An inch was the width across your thumb. So if I look at this thumb here, this is just about exactly an inch right here. The inch was the thumb. A hand is still used to measure horses. The hand is normally now taken as 4 inches. A foot, that's our foot like we normally walk with. And for a person who is a male who is about 6 feet tall, a foot is normally 12 inches. So this would be this inch right here. The inch would be equal to the finger. The hand would be equal to 4 inches. The foot would be equal to 12 inches. A cubit is normally the distance from the end of your finger to your elbow, and that is called a cubit, and that is 18 inches. It's been standardized to be 18 inches. even though that may not be your exact measurement. A yard is 2 cubits, or 36 inches. For a yard, this is cubic, as Noah built the ark. And a yard is about the distance for a standard 6-foot tall male from your nose, the tip of your nose, to the tip of your finger stretched out to one side or another. And if you stretch your fingers out to both sides, then you get 2 yards, or this is, of course, 3 feet, and so you get 6 feet. So a fathom is equal to 6 feet. A mile is 5,280 feet. And if you think about normally making when you take a pace, if you do a double pace, like you make one step and then another step and then another step here, the distance from here to here is not normally 6 feet. It's not 2 yards. You don't normally walk for a 6-foot male. You don't normally step 36 inches. You step a shorter distance. And when one takes 2 of these steps, it's not 6 feet. It turns out to be about 5.28 feet for an average person that's marching, like a soldier in the Roman army, which is where it presumably came from. And so if they take 1,000 such paces, double paces, there'd be 1,000 times 5.28, which is 5,280 feet. And that's where we get our mile. And so these common units of an inch, a hand, a foot, a cubit, a yard, a fathom, and a mile are things you should be familiar with and know how to convert. Automatically then, we can look at a square inch, a square foot, an acre. An acre turns out to be a certain number of square feet. And like a square mile, of course, is a mile in each of the 2 directions, just like a foot is the same in a foot in this direction and a foot in this direction, or square inch is an inch in this direction, inch in this direction. An acre turns out to be about the area that a mule can plow in one day. So when a person talks about an acre, that went back to our farming age when we would actually be plowing a field with a mule, and so an acre is about what you could do in one day. From that, you could kind of judge how many acres a person needed, because if they had 1 mule, then they could only do so many acres and keep it up. For volume, we have the fluid ounce, and a pint, and a quart, and a gallon, and a barrel, and a cubic foot. Of course, the foot can be, we can take a cubic foot, or we could take a cubic inch. We could take a cubic mile if we were talking about something enormous like the ocean. And each one of these has a conversion back to our standard units of a fluid ounce, and of course many other units that are used there. I'm not going to give you all the conversions for that. In terms of time, we have the second, which is about a heartbeat. Our hearts beat about 72 times a minute instead of 60 times a minute. But a second is a 1/60th of a minute is 1/60th of an hour. An hour is 1/24th of a day. And a day is about 1/365th point and 1/4 of a year. There's another fourth there. It comes very close to being exactly a year. 365 days and 1/4 more, and that's why we have leap year as being 1 day. That keeps us on track with the days having the sun in the same position. Fortnight is going to be 2 weeks, a month, 28 days normally, about the period of the moon, and of course a century is 100 years. Now mass is not just given in terms of a kilogram, but it's also given in the older sense of a pound or a ton or a stone. As I recall, a stone is about 14 pounds. A ton is about 2,000 pounds. Ton is 2,000 pounds. And then that's the short ton. Then there's a long ton that's more often used, 2,400 pounds. I believe that's correct. And in some cases, in these videos, I will make some small mistake, and it is a challenge to you to make sure you can catch them all. The one thing you should be able to do at this point is you should be able to convert units from one set of units to another. So let's take an example here of how we would do that. Well, one way is there's a built-in program, Units, that you can try on your computer if you go to the web page and bring up Units, and you can type as long as you use an algebraically well-formed answer, like a multiply in between the units or a divide, and you can actually add units if you put parentheses around them in the right way. So if you want to see what 4 yards is in terms of inches, then you can enter that and it'll give an automatic conversion. Always put the equal sign first in the units program. Well, another thing you could do is just do a conversion, which is the slash. This says compute what 4 yards is and then convert it to inches. This is just compute what 100 years is and leave it in the metric system. And the second is the normal unit. We're going to talk about that next. So it'll give us 100 years, or 1 century, in terms of seconds, and tell us how many seconds are in the year. Here, if we say equals 16 gallons, we would get cubic meters, which is in the Scientific International System. But if we put a slash, ounce F for ounce fluid, then we would take that gallon and convert it to fluid ounces and take what 16 of those are. Why don't you try that with your computer and see if you can compute each one of these. In a moment, we're going to show you how to do unit conversions, and I think that if you follow that procedure, you will not make any mistakes. So these are our old English units, and regrettably, the United States is about the only place that keeps these units. And the rest of the world, even Great Britain, has changed and now uses the metric system.